Welcome to this explainer. Today, we are demystifying the real, rigorous neuroscience behind human attention. We're not just going to sit here and talk about focus like it's some vague, abstract concept. No way. We're actually breaking down the literal biological machinery inside your head and giving you the actionable, science-backed strategies you need to finally reclaim your concentration. Let's just get right into it. Tell me, does it feel like your attention span is just hopelessly fractured lately? Like you sit down to work and boom, 30 minutes have completely vanished into the digital ether. Well, if you're constantly feeling overwhelmed by all this digital noise, let me assure you right out of the gate, it is not a lack of your personal willpower. Seriously, what you're experiencing is actually a completely predictable, mechanical biological response to the hyper-connected world we live in. Take this highly relatable confession from a Reddit user who goes by Alt-Shift-It. They wrote, "I keep checking this thing like I'm popular or something. It's actually a problem." And man, doesn't that just hit the nail on the head? It perfectly captures our modern crisis of distraction. We are literally living in an era where some of us are getting hit with over 100, maybe even 500 notifications a day. And let's be real, unless you're an international pop star, your brain just was not built to process that massive volume of continuous interruption. All right, here is our roadmap for today's explainer. 1. The biology of focus. 2. Fueling the brain. 3. Mastering your schedule. 4. Defeating environmental distractions. And 5. The brain training debate. We're taking a journey from the absolute micro level of our neurobiology all the way out to the macro level of our daily environments. Section 1. The biology of focus. Inside the machinery of the mind. Let's dive deep into the brain and look at the actual neurochemical signaling that controls our ability to pay attention. So right off the bat, focus isn't magic. It's actually a super precise cocktail of neurotransmitters. You've got glutamate driving excitatory signals and GABA stepping in as the necessary inhibitory brake so you don't get overstimulated. Then there's dopamine. Dopamine regulates your motivational saliency, basically telling your brain, hey, this right here is actually worth paying attention to. But the real star of the show for keeping you on task, that's acetylcholine. It's the primary driver of sustained attention right there in your medial prefrontal cortex. The crucial takeaway here is that when you actively focus, things physically change inside your head. In fact, engaging in sustained attention tasks triggers a massive 140% increase in prefrontal acetylcholine. Think about that. This isn't just random background noise. This surge is directly tied to the sheer cognitive effort you're applying to process complex info. You are literally pumping more of this neurotransmitter into your prefrontal cortex the harder you try to concentrate. But, there's a catch. We all have a biological speed limit, and it's governed by norepinephrine. See, when you spot something important, your noradrenergic cells fire. But immediately after, they need a brief cool-down phase, a transient refractory recovery period, to be technical. Neuroscientists call this the attentional blink. Basically, your brain literally needs a split second to recuperate, which causes you to blink and completely miss the very next piece of information, if it hits you too fast. Section 2. Fueling the focused brain, physiology and maintenance. Now that we know the hardware, let's look at how basic physiological maintenance, like hydration, acts as the baseline fuel for this whole system. It's crazy, but the data clearly shows that even super mild dehydration, we're talking just a 1 to 2% drop in body water, significantly wrecks your sustained attention and immediate memory. To stop this from happening, you can track your hydration using 3 specific field metrics. Ideally, you want a urine-specific gravity between 1.013 and 1.029. You also need to watch for daily body weight fluctuations dropping by more than 1%. And if you are doing blood work, the gold standard is plasma osmolality, basically how highly concentrated your blood is, keeping it tightly bounded between 280 and 290 milliosmoles per kilogram. Now, this detail is absolutely fascinating. Say you've been working hard and forgetting to drink water. A tiny 200 milliliter sip is definitely going to make you feel less thirsty, and yeah, it'll boost your mood. But objective data shows it is just not enough for your brain. It actually takes a full 500 milliliters of water to fully restore your baseline hydration and get your cognitive working memory back online. Section 3. Mastering your schedule, managing cognitive load. Let's zoom out from molecules and water to our daily behaviors and see how our schedules drastically alter our brain's motivation and cognitive fatigue. All right, welcome to the self-monitoring paradox. You'd naturally think, hey, taking a break whenever I feel tired is the best approach, right? Actually, no. Relying on yourself to decide when to take a break drains your executive function, which is essentially your brain's internal management system. It acts like a continuous self-interruption. On the flip side, using external structured breaks, like the Pomodoro technique, protects your working memory from saturation and completely lifts that heavy cognitive monitoring load off your shoulders. And wow, the performance difference here is just undeniable. Studies on objective exam performance show that folks using structured, externally timed intervals hit an average score of 82%, plus a 20% drop in mental fatigue. Meanwhile, the self-paced control group, the ones just relying on feeling tired to take a break, they only scored 70%. Imposing external structure literally frees up your brain power to learn. Section 4. Defeating environmental distractions. The modern crisis. We've optimized the brain and the schedule, so let's tackle the physical workspace and see how it drains our executive functioning. I really want you to think about this for a second. How long does one single smartphone notification disrupt your active concentration? We already know it triggers immediate sympathetic nervous system arousal. Your heart rate spikes, your pupils literally dilate as your brain scans for a social threat or opportunity. But exactly how much time does that one little buzz steal from your working memory? The answer is 7 seconds. 7 full seconds of active cognitive processing is totally suspended for every single ping. If you're getting 100 notifications a day, that adds up to catastrophic neural inefficiency. And the research highlights something really important here. It's the sheer frequency of these interruptions, not your total daily screen time, that is the best predictor of severe distraction. But hey, phones aren't the only hazard here. We've also got to debunk the whole myth that messy desks foster creativity. Sorry to all the self-proclaimed chaotic geniuses out there, but the empirical data strictly proves otherwise. Visual clutter and acoustic office noise constantly present irrelevant stimuli. Your brain's executive control system has to actively suppress all those distractors, which makes you fatigued and give up on tasks way faster. Plus, every 10 decibel increase in chronic ambient noise is linked to a massive 36% higher risk of mild cognitive impairment later in life. So what are you supposed to do if you're trapped in one of those chaotic, open office environments? Well, you can intentionally deploy the eye closure technique. Literally, by just closing your eyes, you instantly remove a massive visual processing load from your brain. This frees up immediate brain power, letting you reallocate those cognitive resources directly toward memory retrieval so you can actually solve complex problems. Section 5, the brain training debate. Cognitive near versus far transfer. Let's look at the controversial multi-million-dollar industry of computerized brain training games. To understand this debate, we look at the absolute gold standard of cognitive testing, the dual N-back task. This is a grueling exercise. You have to track audio and visual signals simultaneously. To succeed, people use strategies like rehearsal, which is just repeating things mentally, chunking, grouping patterns together, and intuition, relying on subconscious matching, all just to constantly update their working memory buffer. Now, practicing these tasks definitely makes you better at them. But here's a crucial reality check about human cognition. Practicing these games absolutely provides near transfer, meaning you get much better at highly similar working memory tasks. But comprehensive meta-analyses show that far transfer is statistically null. Playing a memory game is not going to generalize to dissimilar domains. It won't magically boost your general fluid intelligence, and it won't make you better at logical reasoning. However, don't write off mental exercises completely. Longitudinal studies, like the massive 10-year active trial, show that engaging in challenging cognitive activities builds what's called cognitive reserve. It might not increase your raw intelligence today, but it massively increases your brain's resilience to structural and age-related decline. Basically, it protects against dementia or natural cognitive aging. And that leads to amazing real-world benefits down the road, like a significant reduction in at-fault automobile crashes for older adults. So, are you finally ready to stop blaming your willpower and start engineering your attention? Now that you understand the precise neurobiology of focus, the literal necessity of hydration, the power of structured breaks, and the heavy cognitive toll of environmental clutter and notifications, what is the very first structural change you're going to make today? Because ultimately, if you don't intentionally engineer your environment, well, your environment is going to engineer you. Thanks so much for joining me for this explainer.